Hey guys, Dr. Brown here again with Kubo Math coming to you from Tarlac City, Philippines. Hopefully everyone's had a great day and you're ready to jump into some calculus. Hopefully my voice will last throughout this. If not, I may have to pause and cough a while. I've had a cold. But I wanted to put together the rules of differentiation. There's really 9 major rules that you need to learn and get firm in your mind on how to do these. So let's jump into it. I'm working with a short cord here, so hopefully I can manage. All right, rule number 1, the constant rule. The derivative or rate of change or slope associated with a constant is 0. You know from your algebra days, if you look at the slope of a constant and you look at the change in y over the change in x, well, the change in y is 0 at y sub 2 minus y sub 1. So the derivative of a constant or rate of change of a constant with respect to x is 0. I'm going to skip this rule and go into the power rule and use it to explain the constant multiple rule. If you take the derivative of a function, the power rule says you can, looking at the rate of change of that function with respect to x, take the exponent and bring it down and multiply it by the function and then reduce the exponent by 1. So if I have, let's say, a function 3x to the second power, and I want to take the derivative of that with respect to x. Okay, I'm taking the exponent, bring it down, 2 times 3 times x to the 2 minus 1. So that gives me 6x. Okay, so let's think about that relative to the constant multiple rule. It says if I take the derivative of a function with respect to x, and the function is some constant times f of x, I can bring the constant to the outside and take the derivative of the function. In the case of 3x to the second power, that means I can take 3 times the derivative with respect to x of x to the second power. So that means 3 times 2 times x to the 2 minus 1, which is 6x to the first power, 6x, 6x. So you can bring that constant out, take the derivative of the function, and then of course we incorporated the power rule to perform the derivative. Now let's look at the sum rule. Let's say I have 2 functions and one of them is, let's say 3x to the second power. We'll call f of x 3x to the second power, and we'll call g of x 2x to the second power. If I add those two together, I get 5x to the second power, and this is saying that the derivative of the sum is the same as the sum of the derivatives. The derivative of the sum is the sum of the derivatives. So 3x to the second power plus 2x to the second power would give me 5x to the second power. The derivative of that with respect to x, excuse me, using the power rule, I take 2, bring it down, 2 times 5x to the 2 minus 1, so I get 10x. Now if I take 3x to the second power, well, let me erase that. Let me put it here. 3x to the second power, the derivative of that with respect to x is 6x. And then we had 2x to the second power, the derivative of that is 4x. So 6x plus 4x is 10x, which is the same value as I had here. So the derivative of the sum is the same as the sum of the derivatives. Using that same philosophy, the derivative of the difference is the difference of the derivatives. It's the same concept. So again, 3x squared minus 2x to the second power gives me x to the second power. The derivative of that with respect to x equals 2x. So I have 2x. Now take the derivative of 3x to the second power is 6x minus 4x equals 2x. So that's the same values I have here. Sorry for it being a little sloppy. I didn't have a lot of board room. Okay. Now the product rule, it says if I have two functions, f of x and g of x, I can take the derivative of the product. How I do that is take the first function times the derivative of the second one plus the second one times the derivative of the first one. So if I had, well, let's go back to this 3x to the second power and 6x to the second power. I'm sorry, 2x to the second power. Well, that's, what is that, 6x to the fourth power if I multiply those together. If I take the derivative of that with respect to x, I'm sorry, I have to keep pausing the video because I'm coughing. Sorry for that. So the derivative with respect to x is 24x cubed. So 4 times 6 is 24. X to the 4 minus 1 is 3. So 24x to the third power. I can get the same answer if I take the first one, which was 3x to the second power, times the derivative of the second one, which is 4x, plus 2x to the second power, which is the second function, times the derivative of the first one, which would be 6x. So now I have 4 times 3 is 12x cubed, plus 6 times 2 is 12, x to the second power times x to the first is x cubed. 12x cubed plus 12x cubed is 24x cubed. So I get the same. Quotient rule, I may not have the room to work this one out, but it's the same concept. You're looking at f of x divided by g of x, and what that means is I take the function that's on the bottom in the denominator times the derivative of the one in the numerator minus the numerator function times the derivative of what's in the denominator, all divided by the function in the denominator squared, and then work that out. So if I have the room here, let's see if I can get around here and work a function. Let's say f of x equals x to the second power plus 1, g of x equals x cubed minus 3. So this function would be saying take the g of x, x cubed minus 3, times the derivative of f of x, which is 2x. So 2 times x to the 2 minus 1, so that's x to the first power, minus f of x, which was x to the second power plus 1. And I put these in parentheses here because it's minus everything over here, times g prime of x, which is 3x squared, 3x to the second power, so 3 times x to the 3 minus 1, all over g of x squared, so x cubed minus 3 squared. Now I'm not going to work that out right now because the video would be a half a day long, but that would be how you would work a quotient. That's the quotient rule. So if you would take a quick screenshot of that, because I need that space to work the next problem. Okay, the next two are the chain rule and the general power rule. If you have y equals a function, it's f of u, but u equals g of x. Now this is not obvious at all, so bear with me. That means y is f of g of x. Okay, again, that's like the other video where you're reaching around the back of your head to scratch your elbow. Okay, the general power rule, I think, becomes easier to explain this one, because if this is y equals f of g of x, and you're trying to take the derivative of y with respect to x, that's the derivative of y with respect to u and the derivative of u with respect to x, and you're multiplying these two together. Well, the power rule, we've already explained that here. But now we're making it a function of u of x. So if I have y equal u of x raised to the n, now if I'm taking the derivative of y with respect to x, it's n times what's in the parentheses to n minus 1 times the derivative of what is inside of the parentheses. The best way to handle this is work a problem, I think. It becomes easier to see. Let's say y equals x squared minus 3 raised to the third power. Okay, I'm going to have to cough again, so I'm going to pause. Okay, apologize for the continued coughing. I've just had a cold, but I know there's people I've met in town at Metrotown Mall that really need this, so I told them I would do my best to get this out. All right, let's let u equal x to the second power minus 3. So I'm just looking at what's inside that parentheses. The derivative of u is, recall the rule where I can take the difference rule. Okay, so I can take 2 times x to the 2 minus 1. Derivative of a constant is 0, so I just have 2x. So du dx equals 2x. Now then, let me substitute. I have y equals u, because I said everything inside was u to the third power. Now then, I want to take a derivative of y with respect to u. Oh, dy du. And that equals 3 times u to the 3 minus 1, which is 2, du. Now to the derivative of what's inside, I should say dy. With respect to u, 3u to the second power du. But what did we say du was? It was 2x. So let's go back. We're in the u world now. Let's go back to the x world. Now I've got to cough again. Okay, so we're in the u world. We need to go back to the x world. So dy equals 3u, which was x to the second power minus 3, du dx, which was 2x. So now 2x times 3 gives me 6x, x to the, oh, I left the exponent off, to the second power. So x to the second power minus 3 squared. So that's how a chain rule and the general power rule would work. You're substituting u inside the parentheses. Now you'll only do this for a while. Eventually you'll just say, okay, that's 3 times x to the second power minus 3. to raise to the second power times 2x. I mean, you'll eventually just do this immediately, but for now, if you'll substitute u, it simplifies this, and then you can work through your derivative, then plug the numbers back in. So those are the 9 rules that you really need to get in your mind if you're trying to go through differentiation. Sorry for the big mess up here, but hopefully it was clear. Now in future videos, we're going to take each one of these and work a lot of problems. So if you're around the Metrotown Mall, which I met some folks today, they're bringing some problems for us to work. And so that we can make it clear. And I'm a firm believer in a pencil and a paper and an eraser. That's all we need, and an open mind, and we can get there. So study these. Let's work on them. And again, my board's really full. Sorry for that. But study the 9 rules, because if you can master these, differentiation will be a breeze. Again, sorry for the coughing and all of that, but I told some friends of mine today that I would get this out tonight. So I think it's 1 a.m. in the morning now, so it's actually the next day. So have a wonderful evening, and keep studying your math so that together we can build a better tomorrow through math. So have a great evening. Talk to you soon. Thank you.